Clustering is a pretty short and sweet kind of lesson. So again, we're going to look at clustering. It's also known as segmentation if you kind of look at it from a marketing perspective. We still really care about this idea of distance. Okay, so we talked about K and N. This is the clustering algorithm we're going to focus on is the K-means algorithm. So if you read your textbook, there's actually two different types of clustering algorithms that your text talks about. If you watch the videos, there's two different videos on, there's both hierarchical clustering and there's a K-means clustering. Because we're going to let the software do most of the work, we're going to use the K-means clustering because that is what our software is handling the best. But for an idea of how the other type works, the hierarchical clustering works, like I said, there's videos and there's readings about that if you want to. But the focus is going to be on the K-means. Alright, talked about that. Where we are. So, clustering. So if we go back to your wonderful, you love it churn data set, one of the things that we could do with churn, right? We can't really predict churn, but maybe we could group our customers into some similar characteristics. Okay, so can we identify clusters or segments of our sample to help market our services better? Right, so we may not be able to predict churn, but if we find people who are grouped together and seem to be having similar talking patterns, can we do something to help market our services better? Our home equity data set, this is what we actually were just playing with, and we'll play with a little bit here in a second. Our idea is 1 was going to be our client was going to default on a loan, or 0 was the loan was repaid. So 1 for bad was they weren't a good loan risk, 0 was they were a good loan risk. And here we can say, could we identify clusters or segments to help us, oh wait, it's the same question. Market our services better. This is actually a big question for clustering. So no matter what your data set is, can we group people in such a way that we can actually do our job better? Okay? Give a more personalized experience. For our Boston housing data, when we were trying to predict if something was on the river or not, can we identify clusters of our sample to aid in determining which area we want to purchase our real estate? Right? Do we want to purchase? So the river is quite large. Where along the river might we want to purchase? Where should we cluster? What should we look for good homes? Okay, so any kind of question like that, where finding a group of people would be useful, is where clustering and segmentation can happen. As far as preparing our data for clustering, it's the same thing. So when we're doing our K-means, our K-nearest neighbor, all of this ties together. So measurement, we're going to be doing distances, so you get to choose which distance you want. Again, the default is that Euclidean distance. And we still need to make sure that we normalize or standardize our data. Because if we're talking about distances, we want to make sure that all of our continuous variables are on the same metric. So those are things to consider. That's as far as your data prep goes. So into the modeling, what this actually is, what is clustering? So our K-means clustering, so this is the algorithm we're going to use. Our target variable is unknown. We don't have a target variable, necessarily. So we don't have a target variable. What type of data mining category is this? So it's unsupervised, so we don't have to go down further. It's just an unsupervised method. It's data-driven, so it's all based on the data we have. And here's our big goal, i.e. a great quiz or test question. Okay. What we're trying to do is we're trying to increase the between cluster variation and decrease the within cluster variation. Right? So what does that mean?
Tighter clusters.
I want tight clusters, so the people in the clusters or the observations in the clusters are very similar.
They're easily identified.
They're very different from each other.
And they're very different from each other. You guys, we're going to fly right into this. So the K-means the algorithm, right? The whole idea is here is we're studying the grouping of records. Take you back to your Sesame Street days, if that was something that you watched when you were growing up. One of these things is not like the other. Right? Our idea is we're trying to find the things that are most like each other. And I feel like I wouldn't be doing my job if I didn't show you how the algorithm worked in the big picture of it. we're not going to actually have to do the algorithm. If you're in a machine learning class, you could program the algorithm. We're just going to talk about it, and then we're going to let our software do it for us. So here, we're doing the k-means clustering. You have to choose the number of k. You have to choose the number of clusters that you want, and that's our starting point. Step 1. Okay. Step 2, we're going to start and we're going to partition our data into however many classes, or however many clusters. Then at each step, we're going to move the data points around to find it to the closest cluster. And where in the closest cluster, we're going to actually calculate a centroid, a middle point. And we're going to move each data point to the closest centroid. And we're going to keep moving these data points. And we're just going to repeat, repeat, repeat. And we're going to stop when no more data points, either when we reach like an objective, like we're only going to do this 5,000 times, or when there's no more difference in the variables, the observations aren't moving anymore. Okay. So basically what we're going to do. So here I have 8 data points. Okay. I decided that I'm going to have 2 clusters. Okay, so my k is 2. That's step 1. Okay. 2 clusters. And I just arbitrarily, randomly assign 2 centers. Okay. So this initial thing is just, I'm going to throw them out. So I randomly assign 2 clusters, and here, cluster for this one is the point 1, 1. Here's the point 2, 1. Okay, the little triangles are my centroids. Step 3 says for each record, I'm going to find the nearest cluster centroid. So that means that for all 8 of these, I have to find the distance between that triangle and each point. So I do that. G is right on my triangle, so there's a 0. Okay? And then I also find, for each of these 8 points, I find the distance from that triangle. Okay? This is the idea. And then it's going to say, which cluster do you belong to? Well, if I have to choose between 2 and 2.24, I'm closer to 2, so you're going to go to cluster 1. If I have to choose between 2.8 and 2.2, you're closer to 2.2, you're going to go to cluster 2. And it really is that simple. It's just looking at distance, who's the closest? Okay? So once I figure that out, then I'm going to recalculate, I'm going to update where the center should be. Right? So here I just randomly put the centers. I just put them out there. Then I'm going to say, well, you know what? If A, E, and G are in one cluster, the center should probably be more like E, not G. Okay? And so the way you do that is you actually add up all the X values, you add up all the Y values, you divide by how many, and that's actually calculating the centroid. It says, you know what, really, cluster 1, you should move up to 1, 2. Over here, there's 5 data points. You should move your middle, it should be over here at 3.6, 2.4. Again, you don't have to do math. This is what's happening. Okay. So I've moved my triangles. Now I'm going to go back to step 3, I'm going to do it again. So step 5 is to repeat steps 3 and 4 until either convergence, so nobody's moving, or termination, which is our max number of times we're going to try this. Okay. So now if I go back and do this, I do the same thing. I say, okay, but now I'm looking for the distance of the first triangle, one triangle part E, calculating all the distances, and then I look for the distance between every point in the other triangle, and everything's good except H. So H used to be in cluster 2, but now it's in cluster 1. Makes sense, right? Like visually, you're like, well, no joke, right? But when we have 1,000 data points, it's not quite as easy. Okay. But so here's where we're like, okay, so we move H, life is good. Step 4 says that's great. So now we have more data points. The data points have moved. Let's find our new centroid. Where's the center of this group? Okay, so we recalculate it, update it, move it around a little bit. Step 5 says repeat. So we do it again. And this time, nobody moves. Everybody's happy. They're in their right spot. So that says we don't have any point switching clusters, no movement. That's as far as we have to go. So this only took us 3 iterations to actually get all the points where they need to go. Usually it'll take tens and 50s and hundreds and thousands, right? Depending on the size of the sample. But that's the idea behind our clustering algorithm.
And you set the number of clusters before you do that?
You pick the number of clusters. So, again, because all the calculations are being done by the computer, and it's relatively inexpensive as far as the time and the effort that it's going to take the computer to do this, try 3 clusters. Try 4 clusters. Try 5 clusters. What is the point? Why are we making clusters? We're just segmenting our customers. We want to be able to do something with our customers. Right? So, market segmentation, we're trying to profile our customers. Right? This is a lot of, like I said, kind of like targeted advertising here. So, how do I not have the slide that I want? Hold on 1 second.
I just have a question.
Yes.
Supposing we are just feeding the number of clusters that I want the whole data point to be divided into, but how does it decide that, okay, and assuming that the data points are scattered, how does it decide that, okay, this particular data point belongs to this particular cluster and not the one that it's...
It's all about the distance. I mean, that's really what it's doing, is that process. It's saying, okay, so it starts out just at a random place. It says, okay, you want 5 clusters, I'm going to pick 5 points just randomly out there, and then I'm going to calculate distance between all the different points. And whoever's closest to my points, that's the cluster you're going to go into. And then now I have a new cluster. So I'm going to find the center of that cluster, and I'm going to update it. And then I'm going to check the distance between all the other points and say, okay, are you staying with me, or are you going to move into a different cluster? Great. Now we have new sets of clusters. I'm going to find the new middle. Once I find that new middle, then I'm going to say, okay, let's find the distance between all these clusters. Are you staying with me, or are you going to a different cluster? And it just goes through that process iteratively. So that's how it decides. It's totally just a function of distance. It's all about, yeah. I mean, it really is just, if you do Euclidean distance, the k-means algorithm is just a function of calculating the Euclidean distance between every single point and the centroid of every single cluster. And the ones that have the smallest, so whichever cluster it's closest to has the smallest distance from that centroid, that's what it's for. And so we did it, and we only had 1 variable. So it'll actually look at, if you have multiple variables, it'll look at the average distance between all the variable distances that you're looking at. So the example, so I'm going to jump to the example, and then we'll go back to the software. So this is kind of where the whole name your cluster comes from. So Nielsen is great at doing cluster analysis, because Nielsen likes to know about people. They want to know those demographic profiles. They want to know who's watching what are they doing. So here, Nielsen's looking at Beverly Hills, California. Okay, 90210, the zip code. And everybody that lives in there. And they say, okay, so we want to cluster all of the households in 90210. So they run potentially a k-means algorithm. They decide that they want, because they're trying to look at a huge population, maybe they want a lot of clusters. Maybe they want 16 different clusters or 20. Maybe you only want 2 or 3, depending on what your objective is. Maybe here they have at least 16 different clusters. And one of the clusters that they have, they don't just leave it like, hey, cluster 1. No, that doesn't help you out a whole lot. They say, okay, so cluster 1, now that we've done this clustering, let's see if we can actually figure out who is in cluster 1. So they start to say, well, on the variables that we have, this actually winds up being the nation's most exclusive address. They have, most people are between the ages of 45 and 64. Okay, so if we had an age variable, they're looking at that. They have the highest concentration of residents earning over $100,000 a year. So we're looking at income. They've got the highest income. They're looking at education, and they say they've got the highest, so nobody has more postgraduate degrees than the people living in this cluster. And so then they start to tell a story around it. Right? It's the exclusive address. They decide to name it. Name that cluster. It's the upper crust. It's the wealthiest lifestyle in America. It's a haven for the empty nesting couples between the ages of 45 and 64. No segment has a higher concentration of residents earning over $100,000 a year, possessing a postdoctorate degree. No one has a more opulent standard of living. So they have a definition. We have cluster 3, they called it the movers and shakers. And when I said that, did you get a picture of who lived in cluster 3? And cluster 7 is the money and the brains. Do you have a different picture? When I go to cluster 16, it's in the Bohemian mix. You really have a different picture now, right? So you're not confusing cluster 16 and cluster 1. They're different groups of people. Depending on who I'm interested in, what I'm interested in targeting, I'm not going to go to the area of cluster 1. I'm going to go to the area of cluster 16. And whether that's a physical, actual region, or if it's just as I'm doing mailers, the people who fit into cluster 16 are the ones I'm interested in targeting. This is what clustering can be used for. So what you'll see, if we name that cluster, and we're going to cross our fingers that SPSS is going to let us play real quick. Well, actually, so here I created 5 different clusters. And it talks about the different variables, and then it tells you the different characteristics of the variables. And part of your assignment coming up, so you're going to create clusters, and you can decide how many you think are appropriate. And then you're going to try to name those clusters. Who are the people in your cluster? It's already coming up for clusters. He's like, right, so you're going to be doing a heart disease, right? There's people who die, there's people who don't die. Right? Is that a possibility?
Sure.
That actually is a possibility. You may have a cluster of here are the people that die. Right? But then, what can we do with that? If we have 3 clusters and people don't die, and 1 cluster where people do die, I'm interested in that 1 cluster. Right? What's the difference from these 3 and this group over here?
What are the parameters?
So then, exactly. So then you start to figure out what are those parameters. Right? So yes, death seems to be one of them, but what is it? How does the heart rate? How does exercise? How do all these other things factor in? And then you can start to kind of name them and come up with some interesting ideas. 3, 4, 5, 6, as many clusters as you want, but just realize you have to name them, so you might want to stick with a smaller number. Okay. But you're going to make clusters, and you're going to try different cluster sizes that'll help you figure out what you're interested in. So let's play.
Is there like graph for this also, like the ideal value of number of clusters?
There is not. Because it's just an exploratory, it's an unsupervised, we're just trying to figure out what's what. What may be good for me is not good for you. So whereas with the k-nearest neighbor, we were actually trying to minimize error. Here there's no error. Here it's more just about how well does my cluster answer the question that I'm interested in. So yeah, so since it's an unsupervised task, there's no metrics. It really is just an exploratory thing.
But how do we evaluate that the output is valid or
Does it make sense?
does it make sense? Oh.
That really is it. Right? So valid is in the eye of the beholder. So Rachel may come up with 3 different clusters. And we'll use the churn data set. And she's got the people who talk a lot, people who never talk, and people who buy all our products. And those are the 3 clusters that we came up with. You may think, that's okay, but I really want 4 clusters. People who talk a lot, people who don't talk, people who buy all of our stuff and talk, people who buy all of our stuff and don't talk. Right? And that may just be like we can't go into it looking for 4 clusters necessarily. But once you try 3 clusters, you're like, that's good, but that's just not quite what I'm looking for to answer my question. Maybe I need 4. Maybe you only need 2. And it turns out that people who buy my people who buy our plans and people who don't buy our plans. That's the two big groups that we look at. We're interested, in the back of our head, we know we're interested in churn, so we may wind up with people who churn and people who don't churn. And then you may find, there's people who churn and do this. There's people who churn and do this. There's people who don't churn and do this, this, and this. So the number of clusters, it really comes down to what's your business question and can you explain it? Because if you can't explain the cluster, then it's not going to do you any good. Sometimes, if you're looking for anomalies in things, clustering is great for finding anomalies. Right? You may need more clusters, but then you may find out, it's like, wow, what is this weird cluster out here? Like, it's not like anything else. And there's 5 data points. Right? Man, what's happening here? Like, maybe I really need to go investigate these 5 things. Everything else kind of fits into a pattern, at least with some other people. But this is just weird. There's a lot of ways that clustering can be used. Normally it's to find like what's happening in the majority. But it could also be of interest to find what's happening with the anomalies. So let's see if the software will let us do this. So we're going to risk it. We're going to go back to SPSS for a second. I'm going to play with, what data set do you want to try? Do you want to stick with this one? So let's stick with our home equity data set. So I'm going to delete all of this stuff. So we have our home equity data set. It's all pulled in, it's set, it's very good. It's good to go. Maybe we've changed our types to make sure everything's happening. I'm going to have to go back to the very beginning, though. I want something that I don't need. I don't need a target. So right now, everything is just going to be an input. So I have all inputs. On my type node there, double checking that everything's an input. Do we need a data partition?
We're not making a model.
Right, we're not modeling. We're just why do I want to segment my people? Let's use all the people. Okay, so we can actually take out the data partition. Do I need to prep my data?
Probably
yes. You need to standardize.
Right, I still need to normalize or standardize my data because I'm talking about distances, so everything's got to be on the same scale. All of my continuous variables have to be on the same scale. Alright, so now we're going to go to our modeling. We're going to look for k-means. Okay, so k-means is going to construct a clustering model. So within, before I go any farther, SPSS is pretty cool. If you look to the, let's see, what's this one? Oh, not that one. So to the right of the k-means, there's a thing called a cohenance. I'll get it right. A cohenance network, and it also does clustering. So I told you about the k-means. There's also the hierarchical clustering. Cohenance is another type of clustering method. You could use this. There is actually a tutorial on doing this. There's also a 2-step clustering model. Here, this is a 2-step -AS. And be real, don't know what the AS stands for. I have to look that one up. The analytic services.
it isn't the
How's that? Oh, I don't know. So here we have constructs an anomaly detection clustering model. So there's all sorts of other clustering models that you can play with. We're going to focus on the k-means. So I'm going to connect my auto data prep to my k-means. In my k-means, when I double click on it, I'm using, am I using partition data? Ooh, I'm going to check that box. the number of clusters. So the default is 5. We'll start with 5 and then we'll go from there. That's really all I want to change there. Okay. So we're going to run and see what happens. Got something. Results. All right. So someone was asking, you were asking, how do I know if it's good or not? Right. There is one measure that we use. It's called the silhouette measure of cohesion and separation. That's what this guy is down here. So right now, our whole goal behind clusters is we want everything tight within, but then we want the cluster spread out. So here what they're saying is based on the data that we have, if we use 5 different clusters, it's not that spread out. So we're still making clusters, but they're not really separate. Okay. That being said, we can still look at stuff. Or maybe we want to see if we can make this a little bit better before we try to investigate it.
Is there a way to know if you have too many or too few clusters? Okay, so
Trial
you just
and
try
error.
both.
Trial and error process. So I'm going to exit out of this. So I'm going to go back into my k-means. Oops, sorry. And I'm going to say instead of 5, let's do 4. Is it the same? That's still not very good. So I'm going to try 6. I'm going to try 3.
10's a little bit better.
10's a little bit better.
It's unfair.
You heard?
Yes.
Did we remove any input?
Oh, did you change the target?
You change the target back to an input.
Yeah, I did.
That should have been all good.
I didn't do any 13
It
inputs
says 13.
when I followed everything else down like that.
It goes to you.
Does it make it better?
To do what?
Does it make, well, I should do like, are your answers coming up better?
You
have
is
13?
in fair. I'm in fair. Like,
Oh.
I'm in the yellow. I don't.
So
I'm talking as
go look at, so anytime, so this is like the perfect thing. You're like, well, you have 12, I have 13. The best thing to do is to take a type node and stick your type node off of whatever node you're looking at. Yes, not off of your model node, but off of. And then see what's in there. This is
Yours is still a target.
mine is still a target.
Did you hit apply before?
Well, mine's target too.
So it's input here.
Did you hit apply though?
Uh-huh. So it's an input there,
So mine's
Mine is an input.
Mine is also input.
and it's an input here. But when it's coming out, it's saying it's a target.
Also mine. I'm trying to
Interesting.
Why?
Go SPSS.
Oh no.
Did it all restart?
Now let me start.
You thought you don't have any errors, didn't you?
You go ahead.
You thought there are no errors, didn't you?
I thought we were going. Thought it was going to be good. We can still talk about it.
Yeah, it's not pulling my back. Interesting.
So you're saying yours is
It's whatever you're still reading that.
I'll check.
mine's okay.
I have 13, but the type the bad is removed. It is not even there. in output.
Well, right, and it shouldn't be. So the fact that I have, because I only have 12, so that's what we're trying. So did you start from scratch, or did you just replace?
From scratch. I replace it.
Yeah. So I think if you start from scratch, we'll get the right
Start
start.
from scratch.
Delete it.
Delete everything. Okay.
Done. That's my favorite part.
It's like, I like this. Just start over.
A little higher there.
And sometimes start from scratch can also mean to re-import the data.
You're fine, Chuck.
It explains. It doesn't even. You think this isn't even an issue? Is this even a pie chart? Or is this just a collection of? That's a pie chart.
4 nodes.
Import type out of the
Looks like it's a pie chart in text.
And you at the bottom.
Every
Each one of them is like.
Nice sense.
like
All right, I'll do it one last time.
We have to read it, don't
That's the smallest cluster.
we? Or like,
One.
I already did.
So for those of you guys who are working, just keep playing. See what you can figure out for the best cluster size.
I did 100 and I got halfway into fair.
Yeah, I did 30 and I got half a million.
Yeah.
So then the question becomes, if we have 30 clusters,
Yes.
can I interpret them?
No.
absolutely.
I used 4 clusters, but I had a PCA in between, and with the types, I changed the target to input. But when I had PCA and 4, the score, that score.
So the PCA made it better. And so this is kind of the, and I know this seems crazy, right? But I'm hearing, well, I did this, well, I did this, well, I did this, well, I did it. That's part of the data mining process. It really is trying out different combinations, trying to see what works best. Because what is your goal?
Destroy everything and make the game.
I don't think PC is a good idea here because you'll not be able to interpret that. Because clusters all about interpreting the clusters.
So the PCA is going to be, having to interpret it is going to come back to make it much harder to interpret. Absolutely. Right, so it may give you a better model, but then is the model easy to interpret, which becomes kind of like the take-home message, right? So yes, I can get a better silhouette value if I do a sample size of 30, but can you interpret it?
Is there any like trend that we should look at for like the ratio of the cluster sizes to help us determine what maybe an ideal number of clusters?
Watch this.
That's gonna take forever.
Because there is no ideal number. Like that's kind of the thing, is it's what works the best, what's spread out the best.
Full confidence in
So the next thing to actually look at, let me actually put this together. So I did my data, I went through the type, and standardized my data really quickly. Well, let's actually talk about like what we're getting out for the output.
What's your value? Worse than 30. We don't know the value of
So whatever I get, no matter how many inputs I
It's
have.
beautiful.
24.
So now I have 13 endpoints. I've gotten a little bit into fair with 5 different clusters. Okay, so that's actually using bad as one of the clusters. If I wanted to go into 4, just to make it a little smaller. Still fair. So I've got 4 different data points here. So I have 4 different clusters. The smallest cluster is 179, so it makes up just 3% of my data. The ratio of the size of the cluster really doesn't matter, right? So it really is just that idea of, here, let me tell you, you have a small cluster and a large cluster, but that can be okay. Now, if you're trying to get equal sizes, then yes, that makes a difference. But there's nothing that says that I need an equal size, right? So what are these clusters? And that's really what it kind of comes down next to. So here we have our model summary. Down here at the bottom, you can actually click on the clusters. A little bigger. Down here we have a pie chart, which looks fun. But you can look at the predictor importance, kind of telling you which variables we're using the most. Right. So here it seems the type of job seems to be kind of important. Right? We're clustering people by job, we're clustering people by why they want this particular loan, we're clustering people by if they defaulted or not on their loan. These are kind of the big top variables we're looking at. You can also shift a different, and you can look at the cell distribution. And so when it says cell distribution, you actually have to go over to the left side and click on and highlight a cluster, and then it'll tell you about that cluster, kind of visually. The really great thing here with this cluster comparison is, let's say I want to compare cluster 3 and cluster 4. Or I want to compare all 4 of the clusters. Okay, so I'm just selecting them in the left hand, and they're being added to the right hand side. So now, so on the left hand side, I can see that cluster 1 and 2 have bad as 0. So these are people who are not defaulting on their loans. And cluster 3 and 4 have people who are defaulting on their loans. Right? I see the same thing over here in the cluster comparison. Clusters 1 and 2, people are not defaulting. Clusters 3 and 4, people are defaulting. Size of the circle makes a difference, right? Cluster 2, most of the people aren't defaulting. That's great. 1s, yeah, we got some people defaulting. Then we're looking at jobs. Cluster 1, these are the people who default, who happen to be managers. Other seems to be a really big category here. So I don't know that job's really that informative. So if we don't have a lot of information about the job, and we have a lot of others, then maybe we want to go back to our model, take job out, and see what happens next.
Or expand the others.
Or expand jobs.
Expand others, because everything seems to be in others. So expand.
Right, if you look at, yeah, those were the options that they had, yeah. Right, so if that's not a good data point, if it's not giving us a lot of information, then why cluster on that? So then we have home improvement, or if they're looking for a debt consolidation. So most of the people in cluster 3 defaulted on their loans, and they were using that loan for debt consolidation. Whereas most of the people in column or cluster 1 did not default on their loans, and they were using it for home improvement. So right now, if I had to come up, just using those first 3 things, if I had to come up with a name for cluster 1, right here, what might you call it?
I mean, what's also the name of improvement? You could say the DIYers.
It's the DIYers, right?
That's what it actually wants.
Right.
So the good
It's a good deal.
DIYers,
Yes.
right? So you could say, these are the home improvement people. Or you can have a little more fun, be a little bit more creative, let your fun side out. Right? Those are the DIYers, or they're, I don't know, fixer up fast. Something that has to do with good to pay it back. So then you start to look at, and maybe we need something else. Now we have, these are the people who are going to default, and they're managers, because this stands out, right? So you can come up with a name that would kind of go with those.
Chris.
Obviously, it would be the defaulting managers, but if you come up with something just descriptive, that's great. Creative and descriptive is even better. So this is kind of the idea of, can we figure out what's the difference between the clusters? Okay. So between cluster 1 and 2, the job seems to be making a difference. Between clusters 3 and 4, between clusters 1 and 2, it really seems to be the home improvement versus like the reason. Between clusters 3 and 4, it seems to be their job. If we scroll down a little bit farther, you can see other variables, less important, but you'll start to see, so here, cluster 2, cluster 1 are the same. Here's what changes. So here's the delinquency. So that light blue group, which happens to be cluster 3, who's not paying back, they're also very delinquent. So not only are they not paying them back, but they're even more delinquent than these people who are paying them back. They're just a little bit delinquent.
How many clusters?
Right. So the idea behind these clusters is once you find them, then just trying to figure out what separates them from each other. And being able to name that cluster. So SPSS is great, but we also have this other wonderful software that does clustering too. So in VIA, here's what I actually have you do your homework assignment on. SPSS, that's just for fun. Although honestly, I'm struggling with VIA right now. I'm going to be really honest with you. I was really going over using clustering and preparing for, I actually did prepare for class, with the clustering algorithm, and I like some of the visuals for VIA, but I'm a little more concerned with the algorithm that's happening behind the scenes. So, if I go and create a new report, I'm crossing my fingers that this is going to work. You guys look at some new data. Hopefully you should be able to see, you still see a churn data set? What data is available to you? This is actually my new question. What data do you have available?
Yeah.
I don't see anything from here.
There's nothing from me.
No.
So it's just whatever data you have in there.
No,
There's other
it's
data in there.
There's a couple.
it's for random IDs.
So is it ALW084?
Yes. Yes. And IDA statement JXT037.
And Razorback, and
Razorback
Universal.
storage from our freeze.
Okay.
And Universal Bank from S and Nolan, and that's it.
Okay. So nothing from me anymore. So remember how on Saturday or Sunday we had this big overhaul of the system? We're still working on some things. So let's use Razorback stores, because everybody has access to that. We'll use Razorback stores, and we'll just click OK. I need everything sets up. The only thing I would do is I would go change loyalty member to make it a category variable. That's all we really need to change on the data for right now. And then we're going to go to objects. Scroll down pretty close to the bottom, and we'll find our SAS visual statistics that let us do clustering. Just pull a little cluster over here.
What about all the dummy data?
We're going to ignore that. Yeah. Because I don't want to have you move it when I'm just going to say, let's not use it anyway. So this is kind of what the clustering is going to look like. So we never really got a picture of what the clusters looked like with SPSS. So with SAS, you can actually get a picture of what the clusters look like, both in EM and in VIA. So what we're going to do now is we're going to go to the roles, and you'll notice there's no like response or what it's like. I know it's unsupervised, so I'm not even going to give you an option. So the things I'm going to pick gender, I'm going to pick loyalty member, marital status, method of payment, type of customer, maybe the net sales, and maybe the previous store visits. Okay, you can pick whatever. Those are the ones I'm going to start with. I'll click OK. And it's going to do its thing. So the two big visualizations that we have here, this is kind of like a little heat map saying, here's where all the different clusters are. And so one of the problems we have with our Razorback store is the majority of our people are female. Like 80% of our customers are female, we just have a few males. So when we're clustering, do any of our clusters predominantly have males? No.
I'm going to say no.
So each of these little X's, great, sorry. Each of these little X's represents a cluster. Okay.
Okay.
And if you hover over an X, it'll tell you. So here, the gender is female, the type of customer is regular, and this is cluster ID 1 and 4. So the color of the cluster matches right here. So here, if I'm looking for this teal green, let's do the yellow because it's easier to see. The yellow is cluster 5. So here, I have a female that is fitting into the promotional category. This X tells me I'm a female with a razor card. This tells me I am a female that's married. A female that is a loyalty member. Right now it's looking like, so for all the female, they're all kind of in the same categories. Here we see a little bit of difference, but that's just from different variables. Right, so if we come over to loyalty member, we have loyalty member yes and loyalty member no. They seem to all be clustered with loyalty member yes. We got married versus single. All seem to be in the married category here. Right, so we're not having a lot of diversity with these 5 clusters. Right, so most of our people are female. Most of them are going to be loyalty customers. Most of them are married. So the thickness of this line kind of tells you what's happening. Most of them use the razor card. Most of them are promotional customers. So with 5 clusters with this data set, it's just really not all that telling. So in the options, we can change and we can look at, well, let's use more clusters.
So are the X's showing the central points of each of these clusters?
They're showing the most common. They're showing where the cluster is happening the most. So now I went up to 8 clusters. My clusters, the majority of my people are females. Here now I have some loyalty customers. So this cluster right here, cluster 4, seems to actually have my non-loyalty customers in it. I finally figured out how to get my non-loyalty customers. But everything else is still over here. And it looks a little crazy here, right? So you can follow each cluster and see predominantly female, predominantly loyalty customers. But here, that blue line, that's where I'm actually getting some non-loyalty customers. That's where cluster 4 is actually showing something different. So if I'm interested in my non-loyalty customers, that's the cluster I can now start to dig in on and learn more about them. Now yes, could you just filter by non-loyalty customers? Yeah, you could. The idea of clustering is hopefully we'll find some insights that we haven't seen before. The only thing that I'm not 100% sure about, being totally honest with you guys, is if you'll notice, here are the roles. In what order did I put these in? Gender, loyalty member, marital status. So it is actually alphabetical. That's just crazy.
Well,
but
the categories are alphabetical.
they're also in the same order that I put them in here. So it's alphabetical. It's the same order. So like we don't see net sales in previous 4 visits. If I go to my options and say, you know what? I don't want to just see 5 visible roles. I want to see 7. I can't, because I can't have a value bigger than 6. But if I want to see 6 of them, then the next thing that I expect to see is net sales. It's going to be mad at me for a second, because it's like, I don't want to do net sales. So the only thing that I'm not sure about, it looks like it should be, so here's the cluster analysis. It says, so this 4G right here, what this is doing is it's basically saying, I'm telling them how many Ks to use. it's using a standardization process. If you expand this data, you can actually go look at, so here's the customer summary. Without just having to find like little X's, you can actually see what the customer summaries are. But it's using all of these variables, right? So with the cluster, it's not looking at predictor performance. It's not telling me which are the best variables to do. It's saying, well, you used all these variables, so I'm going to cluster based on all of these variables. So there's not a feature selection happening. And in fact, the way Vi is going to display it, it'll display at most 6, and it just displays your top 6. So it doesn't display the top 6 that help the cluster. It just displays the top 6 that you have in there, either alphabetically or just the order in which you entered your data. So I didn't realize that until actually playing with it for quite a bit. Because if you look, it actually says like there's model information. It tells you the clustering algorithm it's using is called, it's called K-prototypes. And K-prototypes, what it is, it's K-means, but it lets you use both categorical and continuous variables together. So I mean, it says that it's using it, and that's how it's deciding which cluster things belong in. But as far as the visualization comes, it's going to use all the variables that you give it. Okay, so you may start trying to move some variables around. It doesn't, it's just not quite as fun as SPSS as far as these are the top 3 variables as far as importance in your data. So pros and cons. Pros and cons.
So how would you classify, like how would you name a cluster here? I'm not understanding anything.
So here naming the clusters, right? So here, let's say we go back down to 4 clusters. So I'm going to go down to make this easier, right? I go down to maybe like 3 visible roles. And I'm going to go down to 4 clusters, so that way it matches kind of what we were doing before. Albeit it's on a different data set. Minimize that so I can see these X's a little better. And so what I would have to say, so for cluster 1, I am a female loyalty member. I mean, that's like looking at these, there's not that much difference. So these 4 clusters,
They're all the same.
they're all the same. So this just isn't a really good data set to get good clusters out of. So that's where we were talking, like if we get up to 8, I mean, you can start to get down to, so let's go. If I expand, then I can see, so cluster 1 is, they're all females. So because it's a classification, it's majority rules, right? So in cluster 1, the majority are female. In cluster 1 through 4, the majority of them are loyalty members. The majority of them are married. The majority of them are using Razor cards. The majority of them are promotional customers. The only thing that you can finally start to do is when you get down to net sales and previous store visits. That's where things differ. So if I wanted to see something different, what I might do is say, okay, I'm going to keep these first 4, but for the roles, I want net sales and previous store visits to come up here. Now it looks a lot crazier, right? Now it's harder to follow because our net sales are individual values, right? But kind of look at this. This green circle right here, this green ellipse, ID 3, these are our higher spenders, okay? Which we could have told by these values right here, right? 3 has an average of $240, so these are our higher spenders. Right? Cluster 2 are our lower spenders, which makes sense. They have an average of $89.90. Okay. So you actually have to play and move things around a little bit more. It can potentially give you nicer visualizations. Make that. All right, so now you can actually start to see how the clusters are separated. So fun, potentially a little bit more visually appealing, potentially not. You just have to work with it a lot more. Alright, so what are you guys thinking? Yeah.
So, do you want us to like mess around in here, or could we, in theory, do it in SPSS modeler first and kind of get?
I'm good with doing it in SPSS first, and then coming here and trying to visualize it a little bit better.
Okay.
So like if we were using the home equity data set, I'd look at those top 3,
Yeah.
and then I want to make sure that those top 3 are the ones that I put here as my top 3.
Okay.
That absolutely.
Okay.
So use all of your resources. Ideally, this should visualize and this should give us a picture. So like if I was going to show someone, and I don't know how to make this bigger yet, this is something we've been playing with. This picture right here actually shows how our groups are separated pretty well. That would be a good visualization to say, well, here's group 1, group 2, group 3. But, yeah. So, on that fun note,